And I'm gonna have.
Cool. Very good. I'll be quiet. Did they adjust it for elevation? Did they adjust it for elevation?
Okay, you know what? I think we'll get started. We're a minute or two early.
Yeah, that's fine. It's actually, that clock is behind. It's actually 12:15, so we're good.
Oh, okay. All right, great. Welcome to our first weather discussion of the semester. I think the last one was like May 4th or something like that.
Sounds about right.
A long time ago. And it turned out that was the beginning of a really interesting summer. We had, until about the beginning of August, we had only one period in that entire May 1st to August 1st of 5 straight days with no rain. And we were way above average. I think we probably still, I should have looked this up today, we probably still broke the record for May 1st to September. We did, May 1st to August 15th. We may have fallen short May 1st to September 1st, wettest period ever in Madison, but we didn't fall short by much. But it's only because it's been very dry in August. And I think we just, right at the end of August, we had just finished a 9-day period without precipitation, consecutive days, which was the longest streak of the entire summer. And it got me interested, but I haven't looked back and seen what's the sort of median longest streak in a summer period. And I suspect it's probably around 9 days, but we struggled to get to that one time. It was probably quite unusual. So very wet summer for us, and great for vegetables. Well, I got a cherry tomato plant. I've got like 300 cherry tomatoes off of this thing already. It's got round 4 coming right now. But you know, there's something interesting about it. When the plants go to the 4th generation, they can't keep the membrane on the fruit for quite as long. The first generation or the second one can really be robust. You can let it hang on the vine. Can't do that anymore. So it's aging, just like, you know, all of us. Interesting, isn't it? So, some more than others. If you've never been to our discussion before, we do it every Friday from 12:15 to about 1 o'clock. It's informal. That means you can come a little bit late. If you do come late, come through the back door. If you leave early, go through the back door as well. You can bring your lunch, crack open a can of pop, whatever it is. I call it Coke in New England, no matter what it is inside the can. And so don't worry about any of that. Don't have to raise your hand if you got a comment or a question. That's the way we try to run things here. Invariably, this discussion turns into a short seminar on some aspect or another that we find out of the week's weather or the day's weather. And we usually split it into 2 halves. There'll be a half where someone will talk about the current weather and some aspects of that. That'll be me today. And then someone will talk about the forecast. And probably that's going to be Patrick Beatty today. Next week I won't be here. I'm going to be in Chicago, so I can't be at the discussion. So and I don't want it all to be on Patrick's shoulders. So we really do want to have other people get involved. And certainly some of you senior undergrads will be in a position several weeks from now to feel a little bit more confident that you could give it a try, and certainly in the spring. And then others of you, some of you senior graduate students, maybe have to start stepping up too to try and fill in the gap. Because it is nice to come in, especially for me in the spring, to come in and take a seat as opposed to stand up here, because I just come out of class in the spring. And it's not easy for me to give a decent discussion right after class. I haven't had time to prepare. In the fall, I love it. I spend all Friday morning thinking about it. So I get to be really in tune with the weather. So anyway, that's the broad introduction, and welcome, and I hope you can make this part of your regular routine. If you know, as I say, it's not a class. If you can't come every Friday and you've got to travel or something, of course, there's no problem at all. You don't have to tell anybody you're not going to be here. And you can come in, as I said, late and leave early. Okay, so Pete puts these 1-week-long satellite movies together that are really spectacular sometimes. And you know, as you know, we're entering the season now where they're just going to be one after another of these gorgeous events. This is the one that caught my eye right away. So we'll get back to the beginning of the week in just a second. It's a beautiful cyclone up in northeastern Canada. And you'll see, and this is in the infrared, you can tell by the land getting darker in the day and then grayer at night. And so you can see the diurnal cyclone temperature. Look at that gorgeous cyclone roaring across Hudson Bay, That's storm number 1. I think there's a second development that comes along later in the week. There's this one here as it moves into the western part of the Labrador Sea. So raking the Labrador Sea, churning up the North Atlantic circulation. So beautiful storms. Notice the latitude though, they're in central Canada. And that's characteristic of the late summer, early fall. That's where fall, autumn, winter is right now. We'll see that reflected in the 850 millibar temperature. When you get to the 0 degree isotherm, that's about where fall is. And it's not here yet. It's still in central Canada. So it's going to make its way southward. It's not, even with this cold snap that's coming up this weekend, it's not going to really take residence in the state of Wisconsin, Minnesota, or North Dakota, but it's going to get close. So that's the march of the seasons, measured by 0 degrees Celsius at 850, but also by the presence of all of these disturbances at relatively high latitude. We don't see them. So we're getting now the frontal passages of these storms that develop to our north with a greater frequency than we did in the summertime. And they really can change the complexion of the weather. I mean, the dew points outside, we'll see in a minute, are considerably lower now than they were just 2 or 3 days ago when it was muggy again, And so, though we still will have episodes of that kind of weather, they get crushed with greater efficiency and greater regularity now than they do in July and August. And that's a good thing when you're wearing a tie to work every day, I can tell you. Okay, so broadly speaking though, look at how boring the Atlantic is right now. We're about 6 days shy of the peak of the hurricane season. September 12th is when the most storms in the Atlantic Basin have occurred historically. And there's really nothing going on in the Atlantic Basin. It's a little bit off this map, but it's not anything that has great hopes for success in terms of development. There are a couple of things that maybe had a tropical origin. We'll see this thing that kind of gets built up here at the late part of the movie off the coast of New England. I think that had origins in the tropics, and it is a kind of an extratropical cyclone that drags in some tropical moisture in this location, but I think right at the end you're going to see something that develops kind of nicely right about in this region off the Jersey coast. Here it comes. And that looks like it started out with a tropical flair to it, and that's now extratropical, and just to the southeast, a couple hundred miles to the southeast of Block Island and Martha's Vineyard. So that is maybe not such an easy thing to categorize. We're going to see today, though, the thing that I want to focus on, and I think Patrick will talk about in the forecast, is late in the, let's go away with the weekly movie, Pete. It's just too much time to wait. I've got one that's a little bit more proximate in time, that's more useful for this purpose. Yeah, that goes, I don't want that one either. Can we go back to the whole North America? Yeah, that's better. And infrared if you don't mind.
Sure.
I'm going to pay attention to a disturbance that's just beginning to show some clouds here over our own state, over the Mississippi River and over Minnesota. And you can't see it so obviously in this image, but there's strong northwesterly flow right across Manitoba into Minnesota. And at the leading edge of that disturbance is a little wave in the broader scale, or bigger scale wave, that is inducing some interesting weather. Now, you look at this and you say, of course, there's nothing really of great significance there. It's not precipitating significantly. We'll see a little bit of precipitation on the radar. It's not well organized, but it's sitting in the middle of an anticyclone with central pressures in the 1020s. So that's interesting. And of course, you have to try and understand what's going on with that. So we'll do a little bit of that. And it turns out that underlying this feature is one of the most fascinating features, I think, in the mid-latitude atmosphere, an upper-level front, tropopause undulation. And it's really weak. It's a wimpy, late summer, early fall example of them. But boy, it has all the same ingredients as the strong ones. It'll come along beginning probably a month or so from now and lasting all the way to the end of March. So we'll take a look at that in some detail. I believe Patrick has some things to say about what it actually means for the forecast. I may even intrude a little bit on aspects of that into the future, but not too much, I hope. So that's what I want to show you. Okay, so let's take a look, Pete, if we can, at the 500 millibar map for this morning, 12Z. Hopefully 12Z is it. I don't think I saw it.
Oops, that's,
Yeah, so
sorry,
that's 300. Okay. So 12Z this morning. Black lines are geopotential height lines. We need some new color bulb or something, huh? The red doesn't really look that different from the black. Sometimes it does. And then, so the black geopotential height, notice the winds are close to geostrophic everywhere, even in the region of curvature. And then the red lines are isotherms every 5 degrees C. And this is at about 3 miles above the ground, 5.5 or so kilometers. This is a deep, cold upper trough. It's minus 28 in northern Ontario right now at 500 millibars. That, minus 26.8, sorry. That's gonna maybe get as cold as minus 45 on the coldest day we'll see all winter long. So we're really getting a shot of pretty decent cold air early in the season here. And then there's this really intense baroclinic zone. Remember, these are every 5 degrees C. It's minus 14 in northern Michigan, minus 13 at Green Bay, minus 13 at Minneapolis, but it's minus 24 at International Falls. So we've got 10 or so degrees, 15 degrees actually, all the way into central North Dakota across that baroclinic zone at 500 millibars. That's fairly intense for this early in the season to see such a strong upper level mid-tropospheric temperature contrast. And so we'll do some interrogation of this feature. Can we take a look, Pete, at, I know it'll involve going to the movie at 500 millibars, but let's do it, and let's go to, we're only gonna concentrate on the last 2 or 3 panels, so I don't care about going through the whole thing, but when we get to, yeah, let's go back a couple. So, right there, Thursday. You see this little thing, this little bit of a wave with a temperature contrast near Great Slave Lake up in the Northwest Territories. Let's click ahead. There it is, much further south into Saskatchewan, and look at where it's just sitting there with a little bit of a shortwave curvature maxima and minus 20, minus 25, pretty chilly. Next one is, I think, what we saw yesterday afternoon, yeah. So this is now over Lake Winnipeg. Winnipeg, Manitoba had 65 knots from the north at 500 millibars, only 25 down at International Falls, 50, 55. So a wind speed maximum right west of the lake, coincident with the strongest temperature contrast. That is a little feature within a broad scale ridge trough couplet over much of Canada. So the ridge axis goes right through the Western Prairie provinces, the trough axis through Ontario, and then up toward Labrador. So right in there is a small embedded shortwave in this broad anticyclonic flow. And at this time, as a consequence of the anticyclonic flow, the ridge is here, and so downstream of it, this broad descent over this region is a giant anticyclone. Pressures in the 10, 24, 25 range at sea level. But something emerges because of the presence of this upper wave. So this was just last night, and then one more is the map we just saw. And you can see the wave has progressed rapidly. South of Lake Winnipeg now, it's over, La Crosse. The axis is over La Crosse. And the trough looks like it's become part of the much broader scale trough that already pre-existed. And so remember that little bit of cloudiness we saw right in this location on the satellite, some hours after this map was taken, but that's right in the region where one might expect some ascent, for reasons that are not particularly apparent from this map, but we'll see that when we go through the rest of the analysis. It's not likely to get warm very quickly because there's no flow across the high terrain, which stretches roughly like that. There's a big ridge over it, so that keeps us from getting the strong adiabatic warming that sometimes gives us really warm fall days a day or two after the air has subsided. That's not going to be the case over this week, not at all. Okay, let's take a look at 300 millibars at this time. And then we'll see, and I won't go to the movie, because you've got a really intense little jet streak this morning right on the North Dakota-Minnesota border, or the border of both Dakotas with Minnesota. That's a fairly intense little jet streak. Downstream of that jet, there's a strip, we'll find this out in a minute, there's a strip of cyclonic vorticity right in this location, partly because of curvature and partly because of the shear. And it's right at the end of that feature that we have the little bit of cloudiness we saw in the satellite picture, for reasons that we'll be able to show quite nicely with Vis 5D. So that's a sharp little upper trough, and the jet feature over western Minnesota is really the last vestige of that independent shortwave that was embedded in that northwesterly flow. And it's showing up as a really nice shear maximum. 117 knots. I don't really know how strong that is relative to Climo in early September, but it's probably pretty good. It's a decent upper feature. Okay, let's go lower than this, Pete, if we could. Let's take a look at 850. What's the air like in the lower troposphere associated with the invasion of this feature? So first of all, here's Lake Winnipeg for reference. And you can see the isotherms have a little bit of a troughiness to them. This is a 0-degree isotherm, so that's fall. And it does make it into the Upper Peninsula, and maybe the Arrowhead at this time, but everywhere else it's mostly Ontario. But right in this location and immediately downstream of Lake Winnipeg, see this little bit of an inflection in the isotherm, the plus 5-degree isotherm. That's probably indicative of a little bit of a struggling lower tropospheric circulation that's trying to get itself organized in that location. and that's immediately downstream of the upper wave that we saw at 500 millibars. So everything that's playing out here is of the weak variety, not only because it's trying to lift air that's in a big region of historic anticyclogenesis, so the stability's high, it's not easy to make that air move in the vertical, but it's also fighting the fact that the signals are pretty weak. But something's getting developed there nonetheless, and we're seeing that reflected as we did in the satellite. Okay, one last thing is let's look at the radar, just to see if any of those clouds that we did see on the satellite movie have anything to them. Just a little bit of showers. And you can see in the sky, the clouds are quite interesting today. They're capped mostly right now over us. You can see, when you look through little gaps in them, they're not very deep. So they're a function of daytime heating with chilly air aloft, but there's a general suppression of those convective towers because there's gentle subsidence in the anticyclonic downstream of the big ridge going on. It's only immediately downstream of the little shortwave that you're going to see anything pop through there, and that's just about coming over us. So we might get a little shower here today. One last thing, I should have said this before. Let's take a look at the 500 millibar vorticity map at 6 hours into the 12Z forecast, if we can get that.
Oh, you want vorticity?
Yeah, thanks. But we'll probably look at that too in a minute. So here's the vorticity map. So look at that. That's really intense, absolute vorticity from west of Minneapolis to just southeast of La Crosse. I think it's in the range of 3 times the Coriolis parameter. And it's rather balled up. Not exactly balled up, but close to it. And then if I leave my pointer right there, did you zoom in on this?
I did, I can
Okay,
zoom in.
we gotta
It's the
zoom
same
out.
though. Go ahead and leave it where it is,
Okay.
because I'll,
Right there is the maximum in the vorticity gradient, most likely. So let's see what the 1,500 thickness looks like, right there, same time. Oh, son of a gun. So here's the thickness represented by these dashed yellow lines. So where it's kind of got a tight gradient, there's a large thermal wind. And right in this location immediately down shear, downstream in the thermal wind sense, from where we had the maximum vorticity, that's where the forecast model has this forecasted precipitation. And that's darn close to the little bit of scattered stuff that we're seeing right now on the radar. That's a function of positive vorticity advection by the thermal wind. 452 and 751 people, you'll know what that means in a couple of weeks. But that's the most basic mechanism for generating upward vertical motion in the atmosphere, and that's reflected in precipitation. Look at where it's happening. 1028, 1024, 1020. There's just a little bit of something trying to develop here in the midst of a really intense anticyclone. So it's really interesting what's going on today. It's not a run-of-the-mill little shower that we might get sprinkled on here in the next hour. It's somewhat unusual. Patrick Beatty's been looking at a version of this kind of development that wasn't so weak, but it was also unusual. And it's been a really interesting couple of years thinking about that. Okay, let's now go to, let's see, what should we do next?
are you ready for Viz 5D yet, or?
Not quite yet. I wanted to download, I think I did download the PowerPoint for the cold pool. Where is that? Let's take a look at that.
It's probably, that's not it. Is it in your?
Oh, it was in my mail, yeah, we were gonna look at this. Okay, so we'll just do it right here. We're a few days past the beginning of September, and I keep track of the aerial extent of air colder than -5 degrees C at 850 millibars. From the beginning of the extended cold season, which I consider to be September 1, and I go all the way to the end of March. With, religious fervor. Other than that, I have it registered somewhere else. I don't really care so much about it then. So this is the average in black from 1951 to 1980. There's a longer term averages in blue and a shorter term, most recent 20-year period, 1981 to 20. Actually, I have to update that. It might be, I should do 91 to 2020. But you can see that there hasn't been much variation in the average aerial extent, which goes up on the y-axis, of air colder than -5 at 850 and the date. Okay, and then the gray lines indicate the all-time minimum and the all-time maximum. I think these days are a residual from last year. We set new all-time minimums those days. And then click ahead one slide, Pete. And that's the first 5 days of September this year in red. So we're below average, but who cares? It's only the beginning of the month. But I keep track of this, and every couple of weeks, I won't bore you with it every week, but every couple of weeks I'll bring this in. And those of you who know me realize I love to win contests of any kind. And so if we can be the coldest or the warmest ever from September 1 to October 1, I will report it. If we're the warmest through October 8th and then it goes away, I'll report it. So it gets to be exciting. The smaller the area will extend, of course, the warmer the hemisphere is on that day. So we're currently running below the average, but not at record levels. Okay, so that's where it stands. And it's only a few days old. Now let's go to Viz 5D, I think will be the best thing to do. I'll skip the other thing I had thought that I might show because this is more exciting. Okay, so here we're looking at the global forecast system model analysis from 0Z on Friday. So this was taken last night. Is that right? Yeah, it says Friday 0Z. Okay, so this was one of those synoptic times prior to the current one. This is approximately 500 millibars from that data in a software package called Viz 5D, which if you've never seen it before, your life's about to change. It is. It'll never be the same after the next few minutes. I just want to tell you, I feel it's an obligation I have to tell you that. These are every 3 degrees C at about 5.3 kilometers, which is close to 500 millibars. And so you can see the map, you can see the temperature contrast. Let's put the vorticity on there, Pete. That's QZ. And I'm going to show you at the same level. Too bad it's white because it looks almost like the map, but I didn't change that. Pete can probably do it on the fly quite quickly. So there's the vorticity at about 500 millibars, and it's the absolute vorticity straight from the model. I don't do any calculation on this. And so if we zoom in the Lake Winnipeg area, you will see here's the maximum in the vorticity. So that's the innermost contour right there. And it's this is 16, 20, 24, 28, 3 times the Coriolis parameter. And then immediately down shear of that, I'm using the 500 millibar isotherms as a proxy for the direction of the thermal wind. That's where one might expect substantial ascent. So let's zoom back out, and we'll take the vorticity off now that we've identified that, and just put the mean sea level pressure on there, Pete. And I've put it at every 1 millibar, because if you do it at every 4, the standard interval, you wouldn't see this. But look at that. That's a little depression in the sea level pressure field. It's exactly where the PVA by the thermal wind is. So that's, look at this. Otherwise, 1025, 1024, that's an anticyclone with a little dent in it, forced by PVA by the thermal wind associated with whatever this thing is in the northwesterly flow. For the fun of it, let's click ahead a couple times. And these are every 6 hours, I think.
Every 3.
Every 3, correct. So there's the cyclone. There's 3 more, and we'll stop here. There's a little trough. You can't miss it. And I wonder if that trough is following the direction and location of the PVA by the thermal wind. I'll already tell you it is. But let's go back to the initial time. Look at it, still in the middle of an anticyclone. Let's go back to the initial time, get the sea level pressure off, Pete, and then let's take a cross section in theta across that feature. So, and just to remind you, put the vorticity back on. I'm using this as my tag. I'm going to cut right through the maximum in the vorticity as many times as I can in this short discussion. So that's why I do it right there. But notice also, we'll take that off now, Pete, the vorticity. I want to make sure my cross-section is perpendicular to as many isotropes as possible. That's going to give me the best look at what the structure of that thing looks like in the vertical. Oh, how will we do the vertical, Pete? Well, why don't we just tilt the view? Oh, man, is that awesome or what? Didn't I tell you? So these are isotropes from the ground to about 15 or 18, 19 kilometers, I think is the top. And where they're tightly packed in the vertical, of course, the stratification's high. That's the stratosphere. You can't miss it, right? Tropopause is right on the boundary of it. But what are these weird baroclinic zones, especially this one, intense? It's on the order of 12 degrees across that with very high static stability. What is that? And it doesn't come down to the ground. Well, let's take a look at potential vorticity on this cross-section. Well, son of a gun, it's a pendant of high potential vorticity. It's not surprising, since the PV is a product of the stratification and circulation, that you're going to have in a region of really strong stratification, high values of PV. That's characteristic of the stratosphere. Well, why do you get these undulations, these little protrusions out of the stratosphere? And why do they pay attention to these baroclinic zones? Because they're one and the same. That's a region of high stratification. It's also, watch this, take the PV off, put the wind speed on in the cross-section. It's also horizontal shear. So if you've got strong stratification and strong vorticity, in fact, let's just look at the vorticity, Pete. How about QZ instead of the speed? Look at that. That's really strong horizontal vorticity. Absolute vorticity. And it's weaker on this one. That vorticity times that stratification gives you, Pete's reading my mind, strong PV. Right? And where the PV, remember this surface right here is the theta at 500-ish millibars. That's a region of strong vorticity at that level. And that's the feature that we're talking about as being responsible for the development of that weird perturbation in the pressure field that has a cloud and precipitation signature with it, right? They're all tied together. So this is all going on at the same time. Let's take a look at vertical motion. Pete, you were thinking it, weren't you?
I was thinking it.
He was. And this is, you know what I did? I changed it to positive. So let's go to the negative ones. We have to change the contour interval. So all we have to do is go in the parentheses, start with -10 and end up with -0.2 or something. Or -0.02. Right now I'm showing you the upward vertical motions. I want to show you the downward vertical motions. And look at that. Subsidence, and put the jet back on, the speed. Here's the jet core, and there's subsidence sort of right near the jet core. Andrea's not here, I don't think, right? There's subsidence on the warm side of the jet in the lower stratosphere, which is frontogenetical. Because this air here is warmer than this air over here, and it's subsiding nonetheless. So that's pretty wild. There's a lower stratospheric front that's developing here rather robustly, and the upper tropospheric front is still getting a little bit more oomph at this time, but it's not going to for long. This thing is probably past its peak in terms of development. But we'll see many examples of this. Subsidence right underneath the jet core is very strongly frontogenetical at the tropopause, and that leads to the protrusion of the stratospheric reservoir of high PV, and if it cuts through the 500 millibar surface, you have vorticity at 500 millibars suddenly that you didn't see before. And down shear of the vorticity, that's where development occurs. All this stuff is, you gotta think of it that way. It's really fun to do that. Okay, let's, is that all I had on this? I think so, yeah. So let's jump ahead like 12 hours, Pete, and then I gotta turn it over to Patrick. There's gonna be too much time taken. Let's put the sealable pressure back on. There's our little trough right in there. If you take theta off, you can see it more obviously. See, that's a little trough in the pressure field that's kind of in a weird place. Let's take the sealable pressure off and put the vorticity back on, QZ. And then theta, again as a proxy. There's the maximum vorticity, so the maximum PVA is like right over central Minnesota. Can we put sealable pressure back on there again? I forget what it looked like. Oh, that's where the trough is. Nice, isn't it? How it all works out. And this is, I want to just tell you this, chosen at random. Not exactly. We talked about it a little bit yesterday, but not in conjunction with each other. And then I thought, I woke up this morning at 4 a.m. thinking, I got to get into work because I want to get this working and see what it looks like. And it met my expectations. But I knew it would. Now let's do cross sections. One more cross section, Pete. This time you got to draw it from 29.78. So move one of them to 29.78. I think that goes down on the left side. I've got to be in slice, I think. 29.78, and then 45.69. It hardly moves on this side. I think it comes down too. Yeah. 45.69. And so, once again, I'm trying to cut just about through the maximum of the vorticity perpendicular to the isotropes at upper levels. We'll have to do the same with the other ones when we start looking at it. But let's, for the first time, let's just turn this up and look at what the thermal structure looks like. Well, that's a really intense upper front. I think it might penetrate further down into the troposphere at this time than it did at the prior time. And I think there's a steeper slope to this bundle in the lower stratosphere. That would be in line with what I think was some upper front, lower stratospheric tilting that's producing a stronger front there. So let's go to the top view again and get the speed along that line, just so we can see what the jet looks like. And then one other thing, what did we do? A PV. Let's see what the PV looks like. And we'll only, when we turn it up, we'll only look at one variable at a time. Let's do that. We don't have to do omega anymore because I think the subsidence has kind of gone away. So let's turn it up, and we're looking now at the speed. So look at that jet core right there. An intense horizontal gradient of the wind speed, which is horizontal shear, And then that shear is coincident with the strong temperature contrast. It has to be, that's a thermal wind in both places. Thermal wind doesn't stop working in the upper troposphere, it works in the lower stratosphere too, of course. So, and where these little polygons made by the wind speed and the isotopes are smallest in area, that's where the PV is largest. That's always the case. And so we've got, and let's take a look at the PV, put it on top there. There's our tendril coming all the way down, still past 500 millibars. And it's much stronger on this western side of this upper trough axis than it is on the eastern side. And we'll talk about that another time, but that's because on the eastern side, there's general ascent going on downstream of the trough axis, and that pushes the tropopause back to where it belongs. But on the western side of the trough axis is general subsidence, and that encourages, in a broad sense, some of the mesoscale processes that are forcing this to be subducted. And so you have an asymmetry in those things quite regularly in that case. And as you might be wondering, if you then prepare the environment by pushing the tropopause down on the western side of an upper trough, what happens when it rolls around to the eastern side? Sometimes a big development. So let's do one last thing, Pete. We'll do the PV surface, take these cross sections off, and let's go to the top view of that. Oh, how come that's not in there? Oh, there it is, okay, I made it transparent. Maybe that isn't such a good idea, but here's the upper trough that we're looking at in terms of the potential vorticity. If you flip it up, we can see the three-dimensionality of this nonetheless. So here's a protrusion of high potential vorticity. This is effectively the tropopause being pushed down locally in this spot. If we go back to the top view, it's right over us at approximately 7 a.m. this morning. Now let's put the sea level pressure on. That's why I made it transparent, because you want to start to see something interesting here. This is a broad trough along which there's clouds and precipitation. We saw the clouds in the satellite picture. But it's really hard for this thing to turn into a tight little cyclone until and unless this broad troughiness in the upper levels gets a little balled up itself. So let's just step forward through this a couple of times at 3-hour intervals. And you'll see this is still kind of an elongated feature in the tropopause PV, but it will start to change complexion beginning about now. In fact, let's take the sea level pressure off just for a second. That's a little bit more tightly wound up, don't you think? Let's go a couple more times. Forward with that. Oh yeah, that's starting to look like a little bit more obvious and central, very local, deep penetration of the tropopause. Let's just see what the sea level pressure looks like at this time. Oh, son of a gun, watch this. Now go forward. That's starting to develop. And it's immediately to the north and east of that upper perturbation of the tropopause. So if we go to theta, take PV off. We're still looking at theta at 500 millibars, and the vorticity, go back a couple of clicks perhaps. Right there. So we've got a maximum of the vorticity right here. There's strong ascent from PVA by the thermal wind in this location. I forget where the cyclone is. It might be a little bit to the east of this, but let's take a look. Yeah, just a little to the east. So this same dynamics is driving some of the development of that cyclone. And this is a result of all of this vorticity at 500 millibars is a function of the tropopause being pushed downwards over the prior 36 hours. And suddenly now it's in a position to be moved around in the vertical. The vorticity is, and that drives the synoptic development. And that's going to be a pretty decent little storm. Maybe it's going to look in the satellite picture like the ones we were just looking at the beginning of the discussion. So, pretty neat. I guess that's all. I've probably gone way too long. Sorry about that, Patrick.
That's fine.
But are there any questions or comments? Okay, strap yourselves in. It's going to be fun. I mean, every single Friday we're going to be talking about something like this. Can't help it. So, okay.
Perfect,
Thanks. Thank you, Pete. Expert driving as always.
Can we start at weather.gov, please? And then I'll come back to this. So, like Professor Martin was saying, it's going to be cold. I'll show you about how cold it's going to get. But there's a tale of two seasons right now. Fall over the eastern part of the United States. It's very warm still in the western portion of the United States. Phoenix, Arizona has, this is 102nd consecutive day of 100 degrees or more. This is the 57th total day that they're above 110. Both of those things have never happened. And there's no end to this heat. This is an excessive heat warning that goes well into next week. So these are all-time records being broken, you know, and not just broken by a couple days, they're being broken by weeks. And this is happening not just in Phoenix, Arizona, most of California and then Washington and Oregon also have had warmest summers ever. And they're still having warmest summer if you call September 6th summer, but it's still warm. And as a consequence, you can see some air quality alerts in this gray color. There's fires going on because of how warm and dry it is in these portions of the United States. But as I said yesterday in 452, look what's happening. We have frost and freeze warnings creeping up. Some in our state, a freeze warning in the Arrowhead of Minnesota, and you could expect in Michigan and then portions of the Northeast that you'll see this kind of band come through as the cold makes its way into the United States. So, and this is all a function of that development, as we saw nicely from Professor Martin. Cold Canada air coming down. So here's fall beginning to creep into the United States. And it's actually producing, if you want to click on Michigan right now, please, let's see. And just scroll down to they have a little radar animation. This is lake effect rain. That's how cold this air is. So it's already beginning to produce lake effect precipitation. And that's how anomalous it is for this time of year. So now could we go back to our AOS forecast page, and I'll use the Python version. And let's go 12 hours at 500, please. So this is a look at tonight around 7 p.m. We're looking at 500 millibars, so trough ridges, and then the vorticity is in the shading here. So as we saw, here's our tightly wound up ball of vorticity, right kind of in the trough axis. If you were to draw, split the trough into a half. So right in the region where we saw that development is going to have a strong gradient in vorticity. I'll keep my cursor here. If you would go to the surface, please, at the same time. 12 hours. Like we saw, decent thermal wind, and here's your precipitation being forced. Even in the forecast model, we didn't see the actual precip forecast, but here's precipitation being forecast in the middle of a 1028, 1024, 1026 high. So that's weird. And then you have another band of precipitation along the front of the developing storm. It's pretty obviously on the warm side of this gradient in temperature as represented by the yellow thickness lines. And what you can see, here's the cold air. This thickness line is 540 decameters. Trace this all the way back up to where it originates. All the way up north of Alaska. That's how cold this air is. On the back side, we're getting the cold air. Here's the replacing warm air that's pushed out all the cold air out of Canada. So you can see how anomalously warm it is as a consequence of us getting the shot of cold air tonight and into tomorrow morning. Could we do the same thing? Let's go 12 hours in the future now to 24 at 500. We can see this trough feature is beginning to ball up. And what I mean by that is you have now pretty close contours in the 500 millibar geopotential heights, and then the vorticity is also beginning to become more circular, as opposed to a feature like this one where you have a strong gradient in the vorticity here. But there still is a decent gradient in vorticity where we saw that development and where we will see the development. I'll put my cursor right here. If we could go to the surface. There's still precipitation being forecast, maybe even a local enhancement of this precipitation because you have the thermal wind advecting that vorticity in the upper levels, and then you also have the lower level front right underneath it. So this is not going to produce any precipitation for our region, but what you can see is this is right near the coldest air. So there might even be some snowflakes flying in southern Canada, maybe making their way into northern Michigan. This is tomorrow morning around 7 a.m. And this is when the coldest air will hit our region. And I'll show you just exactly how cold it is forecast to get. So we might even have some snow pretty close to our area. No precipitation, it looks like for us, just very cold, light winds, exactly what you want for a very cold night. And if this were winter, we might be expecting below zero temperatures, not 40 degrees, which is super cold for this time of year, but it's not as cold as it could be. And then on the backside, again, here's this very obvious thermal ridge in the thickness where if you trace this same you know, these same thickness lines, you can go from Oklahoma all the way into Canada. That's how warm this air is. Okay, and then let's go up 12 hours more or actually let's go 24 hours in the future. So 48 hours. This is Sunday morning. You can see now we have kind of a discombobulated trough. It's very obviously balled up. All the vorticity is just surrounding the trough. So this is pretty late in the life cycle, and we could expect it to be slow moving. There's not a lot of propagating processes going on because it's so balled up. At this time, and you can see it hasn't really moved from 24 hours, maybe gone, you know, the width of Michigan is how far it's moved in 24 hours here. And if we could do the, go to the surface now at 48 hours in the future, we'll see we're still cold, but on the backside, this thermal ridge is beginning to move and creep closer and closer toward our region. So the cold air has shifted with the low pressure. Now it's over New York and into the northeast. But on the backside, here we go. We're going to warm up. If anyone's checked the temperatures, we might be in the mid 80s, high 80s next week. After fall comes in, fall is this little ball, and then we're back to summer.
It's like false fall.
Yeah, false fall, right.
Fall.
Fool's fall is what it is. But it should be a beautiful weekend. What I haven't pointed out is we've been under high pressure this entire time, so the football game will be 60s, sunny, beautiful. You know, just being outside will be beautiful. Low dew points.
Who are they struggling against this weekend?
South Dakota.
It probably will be a struggle.
I don't know. South Dakota's not that good, so we'll see.
Well, we almost lost.
We did last week, yeah.
Come on.
Next week.
And then
Then
can we pull up
Alabama.
tropical tidbits quick?
As we're getting this up, Patrick, one of the interesting things that you brought out in the discussion that can be a focus all by itself is that the geometric change in the forecasted precipitation is exactly corresponds to the change in the geometry of the upper vortex.
That's right.
When that little strip comes around, at first it's very linear, and if it doesn't get isotropic, you can't get cyclogenesis. So that's something we'll emphasize a lot in 452 and 751 is something as elementary as that you can diagnose by looking at the first panel on the chart. You should have some suspicions about what you're going to see at other places.
Exactly right. Yep. If we could go to the thermodynamics. If we scroll down, maybe, yeah. Just how cold is it going to get? I'll show you. This is from the GFS. Okay, so this is about right now 64. That's pretty good. Let's just go to 6Z tomorrow morning. Perfect. So this is now about 1 a.m. 43 degrees for our region, maybe sub-freezing northern part of our state. Let's go one more click. 37 degrees. Right now it's forecast to be 40. This is the GFS, this is one model, but we might see sub 40 degrees pretty close to home. Definitely freezing, sub-freezing temperatures, northern part of the state. Let's keep going to, yeah, perfect. Tomorrow morning, or tomorrow, 58 degrees. One more click, please. Yeah, so like highs in the 60s. And then if we keep going to 12Z Sunday, you'll see the cold air quickly shifts off. Now it's over the northeast. Not as cold as it was over our region, but we may see temperatures below 40 degrees.
Wow.
Just tomorrow morning.
That's great.
And then if you would just want to slowly click forward. Now we'll watch the not fun news. Here's the warm up. Keep going. Keep going. And then eventually it moves into our region. So
What's Thursday like? That's going to be a bad day.
it's short-lived, but we will see some fall temperatures. Pretty cool.
But I won't be.
Yeah. Are there any comments, questions, anything anyone wants to look at before we end? Yeah.
Can you look at Strato Observe?
Strato observe? Sure. What do you want to look at for that?
Like if the polar vortex is starting to form?
You might have to tell me where to go.
Oh, it's in this, and it's the first one on the list. Yeah, I think that's in the southern hemisphere right now.
Oh,
Top.
yeah, if you go here.
Yeah, it's pretty early.
I don't know if that's substantial or not.
Oh, that's not amazing.
looks like something's happening, but it doesn't fully look like a coherent vortex yet.
Yeah, no.
Oh, and then I have another question.
There we go.
That's a little.
There we go. So
And that's by what, 350-ish hours or something?
Yeah, around 300.
yeah,
right around the
so around the
equinox.
equinox, yeah.
Yep.
Yeah.
That's approximately in the window.
There's like a smaller amount of cold air in the northern hemisphere than normal. And we have a cold air outbreak by us over the weekend.
Mhm.
Is it like anomalously wavy then?
It could be a sign of that. If you don't have a lot of cold air to begin with,
I didn't hear the question. Can you say it a little louder, Eleanor?
Is it like anomalously wavy if like the cold air is coming to us, right? Which is kind of lower latitude or?
Oh, that's possible, yeah, that's possibly connected. You know, when you have a high amplitude flow, it's easier to usher out any little bit of cold air that may have started to get itself organized. It won't really start to organize till about the equinox, naturally, because finally then some parts of the hemisphere will never see the sun again, and you can really start to grow the cold air at very high latitudes, getting it ready for export to friendly places like Madison.
right.
So, yeah, but I think that's a good point. I wonder if there's a stronger connection later on in the season than there is early in the season when things are trying to get organized.
Probably. That might be the last of the cold air over the poles too. The stuff coming over us now might just be getting kicked out for the last time before it starts again, so. Anything else anyone wants to ask? Perfect. We'll see you next week then.
Thanks, Patrick. And thank you, Pete.